Let's see how to implement k-means algorithm using sklearn package. We are importing make blobs function from sklearn.datasets. The data required for applying clustering will be generating here with the help of sklearn.datasets make blobs function. Because we need a dataset which is having some clusters inside it. So for that we are using this built-in make blobs function which will generate a dataset with some clusters inside it. Then after that we will be using k-means algorithm to find out those clusters from it. So when we are creating the make blobs function, we can specify how many clusters are there. So with the help of the make blobs function, we will be creating the data set, and then after that we will be clustering it. So you can see the instructions that we have used. From sklearn.datasets import make blobs function, then sklearn.cluster import k-means. This will be used for making the k-means object. Then we will be plotting the result. The clusters will be plotted, so we will be using matplotlib. Then we call make blobs function by giving the number of data points to be generated. The number of samples to be generated is 300, and we are specifying there should be some 4 clusters in the data set, and we provide a cluster standard deviation also. How much distributed the point should be from its cluster center. So 0.6 is given as a standard deviation of the different points in the cluster from a cluster centroid. Then we are creating the data points. It will generate the x and y true values. Let us plot the x and then see the nature of the data set. Okay, I am using plt.scatter to do the scatter plot of x values which is generated using make blobs function. We are taking 0 and 1. By default it is creating 2 columns. So the first column and second column we are using inside the plt.scatter. It is assigned as the x and y for the scatter plots. Let's see the result. And this S is the size of the points. Okay, let us see the result. Okay, so we have created a set of points which is having a clusteredness in its nature. There are 4 clusters in it. So next is we want to identify which are the points belonging to the different clusters. So we are going to apply this unsupervised learning algorithm k-means on this created data sets. Actually this data set can come from any data source. So we have created it here, and then we will be applying k-means in this data set. Let us use the k-means function here to create the k-means object and the model. I am copying the code here. I am calling a k-means function. As we have already seen that k-means algorithm requires a number of clusters as its input. So n underscore clusters, we have given it as 4, assuming that there are 4 clusters in it. So then k-means.fit of x is used here, and as we know k-means is an unsupervised learning algorithm. It doesn't require the output information. It requires only the input points. Okay. So we have given a fit of x. Then our model is ready now. K-means model is ready. Then for the values in x, we want to predict into which class it belongs. So the prediction is done, and the result is stored in y underscore k-means function. And again we will plot a scatter plot with the x and x0 and x1, and we are giving the obtained cluster information as the color of the scatter plot points. We are using a color map here. When we are using some colors, we need to specify the color map also in Python. So let us see the output. Okay, you can see that the different clusters are coming in different colors. So I'll explain this once more. What we have done here is creating a set of points first using the make blobs function. When you call make blobs, the x comma y underscore true, you will get some points into x. It will have by default 2 columns inside it. And then I have plotted it using the plt.scatter function. So you got this. You can see the x values vary from -8 to 8. Y values vary from -2 to 10, because we have created it randomly, so it is creating like the points like that. Then in the second part of the program, we have created the object of k-means and provided the k value as 4. And then we call the fit function to, this is the learning process. Once the model is ready, we do the prediction. By giving all the input points, we are predicting what is the cluster information of these x values. And these results we are marking in this plot with the help of colors. Okay, I'll show you the result of y underscore k means. These are numbers. These are the cluster names. Okay, so these numbers are used for plotting the graph. And also, if you want me to plot the or print the x and y values, x of copy it from here. These are the random numbers generated, both the x and y values. Now suppose we are changing the value of k in this part of code. I'll copy it here once more. Instead of number of clusters 4, I'm giving 3. So let's see what happens here. Even though the data set includes 4 clusters, in our k-means algorithm we are giving only 3 as the required number of clusters. And the same code is executed. You can see that these 2 clusters are considered as a single cluster. Okay, let us see an issue related to the k-means algorithm. When the data set is following some particular pattern, it will be difficult for the k-means algorithm to find out these patterns. Let's see that with the help of an example. I am copying almost similar code here from sklearn.dataset import make underscore moons. Instead of make blobs, blobs will be creating a circular nature of clusters, but here a moon structure will be created. I'll show you the structure. So we'll be implementing k-means, then plotting. We are calling the make underscore moons function. We are creating 200 samples with some noise point. This noise points indicates the deviation of the points from its center of the cluster. Now, we are calling the, first let us see the points. Okay. Okay, we have created the data points using the make underscore moons function. These x values are plotted in the form of scatter plot here. So the moons is created now. Now let us do the clustering part. By the nature of this data set, you know there are two clusters. So when I'm creating the k-means object, I'm giving number of clusters as 2. Then we are calling fit function and then prediction, and let us see the remaining one thing, like we will be plotting the scatter plot after obtaining the k-means clustering. Let's see how it behaves. The y underscore k-means is the two classes. When we use that class information as a color, you can see that the two clusters are formed like this. Because in k-means algorithm, the points will be grouped based on its distance to the cluster center points. So it can create only like this. So we have other methods of clustering here. So there is something called as spectral clustering. When we are calling the spectral clustering, we need to specify the number of clusters, and we need to provide an additional information, what's the nature of the points. We are saying the affinity is specified as nearest neighbors, so that the nearest neighbors will be put into the same class. Okay, so we are doing the prediction, and then again scatter plot. This is not k-means clustering, it is doing spectral clustering. It's a different algorithm. Okay, let us see the result. This is a result. Some warning is there based on the functions, so you may leave it for the time being. So this is the result of spectral clustering. We using nearest neighbors affinity. It has correctly identified the points. Okay.